Check, check. Hello. We are live. Great. Welcome to another Voltage workshop. We'll get into things here in a minute. Let some people show up. Double check we're actually live. Nice, nice, nice. What's going on? We'll get started in just a minute here. Yeah, I am excited to go over this topic. This has been something that I've touched on a number of hackathons and other projects working with people, and I haven't gotten to kind of give it a go with a workshop myself and see if I could break it down into a simple flow. And that's what I often try and do with these workshops is let's get the basic idea of something like L402, a protocol, and let's build a simple example of it. Hopefully in such a way to where we can do it in an hour and then push our code. And even if we completely forget about it, we can go back and look at that code and be able to replicate the thinking process and the understanding and all of that. So hopefully this should be on the shorter side, maybe about 30 minutes, 40 minutes. We'll see if we run into any bugs, but I think it should be a pretty clean operation for most of y'all. Yes, and I forgot to mention, I've got in the top right here, tinyurl.com/L402 workshop. That will actually take you to this repo that I created. And this has the full project, has a README, and it actually has slides as well. We have slides.md. Oh, look, it actually... No, it doesn't show it correctly. If we look in presentation.html, I think, okay. Yeah, so you can open this presentation in your browser. That's what I have here, and that's just the slideshow. So all of the information you need should be self-contained within this repo and then the completed project, of course. But I'm gonna build it along with you from scratch. And so let's do that. Let's get into it. So this is the Voltage L402 workshop. What is L402? What are we going to talk about here? Okay, so what is L402? Simply put, it's a protocol that lets you pay for APIs with Bitcoin Lightning, use services instantly without creating accounts. I like that. And then pay for only what you use, micropayments, paying exactly for what you use of a given service. So think of it as a digital vending machine for web services. I kind of like that as an analogy, like a digital vending machine. And so L402, you know, another name, I think we might have posted this name as like lightning gated API. And that's a pretty nice analogy too. You've got a gate, you got to give me lightning to get through the gate, right? But this can get intricate, right? You can do a lot behind that gate. And with that gate, how long do you have access? How much do you have access? Those are some of the nuances we will not touch on in this workshop. We're going to get the basic gateway stood up, and we're going to tell you how to speak L402 so that you can build your implementation and interoperate with other implementations that are using L402. And you will be able to do very cool stuff with it. I think we have a slide on that. So yeah, that is L402 simply put. The L402 flow, it's a little bit of a flow, but we will walk through here. Okay, so got a tiny bit of a graphic here. Can I zoom in? Kind of zoom in. So the flow starts with requesting access to an HTTP resource. So we're asking for some kind of data, some kind of service through the API. And so the server here, we see it's checking the client credentials. Are you validated? Are you authorized? And it's like, no, you are not authorized. So I'm going to generate a challenge, which is this thing, a macaroon and an invoice. And really what this is it's a token that does not work yet, and then an invoice to pay. And if you pay that invoice, the token will work effectively. So that's what gets baked. So they're baking this response, and they say, hey, this is a paid API. We're going to return you a 402 status code and challenge. And to complete that challenge, you pay the invoice, and then you request access again with proof that you paid that invoice, and they'll give you the data and serve up that requested resource. And so with 402, I mean, like if I go to voltage.cloud/Austin, unfortunately, Voltage does not have a dedicated page for me yet. But we get this 404. It's actually not saying 404. We have a special message here, but if we go to the console, yeah, we get this 404. There is no page Austin. There's voltage.cloud, that exists, but the page Austin does not exist. So this is that HTTP status code 404. Well, the 402 status code, a long forgotten status code, was originally set aside in the 90s, I think, when they were creating the HTTP protocol. And it was never really used. And 402 means payment required. So they were very forward-thinking, the internet devs, and they imagined that you probably would have gated services that need to be paid for. Now, Bitcoin didn't exist back then. They didn't know what it would look like, probably. They maybe assumed it would be credit cards or something like that. I'm not sure. But here we are today, and Bitcoiners, we picked up that 402 status code, and we want to bring Bitcoin to it. Not want to, we have brought Bitcoin to it. And there's a lot of services that are using L402 today. It's particularly powerful for AI and relevant for AI. And so that's kind of the flow. That's a bit about the status code. Yeah, and some practical uses. AI API access, so pay per query, pay per request. This is a powerful one right here. You just think about how prevalent AI is, how useful it is. But the fact that we are all signing up for these services, these cloud services, where our data may be getting tracked. You know, L402 provides a way to where we can use AI models and pay for them, but without giving up our privacy, without creating accounts. That's a powerful use case I really care about. We've got content paywalls, articles, videos, downloads. So yeah, the paywall with which we have paywalls now, but to have an official protocol that other people can adopt, that makes it useful. We've got data services here. Maybe you're crunching data for a user. Maybe you just have a special data set that's valuable that you're serving up, weather, financial, specialized info. So this is very useful for that. Because otherwise, if I have data, it's like I either want to give it away for free or I want to sell it. But if I sell it, I have to take you through this whole process of onboarding and authorization, and then I have to get set up with a payment provider like Stripe, and I go through all this trouble just to sell a few bits, right? Well, Lightning can do it like that. Lightning can do this in a few steps, and the service provider can get paid instantly, and then the end user can get their data and not, need to give up any of their privacy. We've got rate limiting, so this can be a natural spam prevention. Maybe you do have the free data source, but you're like, it's free, but don't request 1,000 times. If you request 1,000 times, I'm going to have to make you pay. So that's kind of the rate limiting use case, and then anonymous access, which I'm just hounding on here because I think that's super powerful with this protocol. So these are just high level practical use cases for L402, but they go far, far beyond. It's just gating data with a payment. Powerful general concept. And so some of the core components we talked through here: HTTP 402, payment required status code. Lightning Network, which we're using for fast and small Bitcoin payments. And then macaroons and pre-image. So macaroons are special authentication tokens. These are usually authentication tokens you create on a Lightning node to maybe allow an app to access it. And then a pre-image is a proof of payment that you get back from paying a Lightning invoice. And so these two second pieces, macaroons and pre-image, these are going to be important because these are basically going to be the two concepts we use to prove that we should have access, to prove that we've paid and get access to the data. Great. So L402 headers. There's a lot of headers. There's a lot of details in the spec. If you go to Lightning, I think I have this linked in the README, do I? So Lightning Builder, L402. Yeah, so Lightning Labs, they have this great write-up on L402 protocol here. So it goes through a lot of the details from macaroons, L402, and some of the history of it. And this is good to go through. There's some technical details, and that's sort of what's in these headers. The headers, this is what confused me the most, but this is how I'm trying to break it down. So you've got request access headers. So these three headers, these are things that are going to be returned to you if you request from a paid endpoint, but you have not yet paid. And we'll see this later. So, you know, I'm requesting from data from this AI, and it returns me this www authenticate. It returns me an invoice to pay, and then it returns me a macaroon, which is a permissions token, but that macaroon isn't really active until I pay the invoice. So this is what we get back when we request access. And then what we want to send back to them to prove that we should have access are these two headers. So an authorization with L402 inside of it, and then the pre-image, right? So this is what we get that proves we made the payment. And then the L402 macaroon that was originally given to us in the first step, right? So we keep that token they gave us, we make that token valid by paying the invoice, and then we just send them both back with headers, and we should get a successful response, right? So, okay, we're talking through this flow a few times. It's probably making more sense. And really, yeah, I do think after going through this a few times, the headers is the most confusing part. But all of this is captured in our code, so you will not have to worry about that. Okay, so let's build our L402 server step by step. I'm going to do it along with you. We're going to create a new code base and stuff like that. And so once again, you can try it out. We've got a Replit demo that I made on the Voltage Cloud Replit. And then the source code is here on my GitHub. You can also get there from the tiny URL at the top. And yeah, feel free to fork it, experiment, update it. Okay, let's get our project set up. Quick overview of what we're going to build, though. We're going to use Express with Express server with L402 authentication. We're going to have an LND connection for creating and verifying invoices. And we're going to be connected to our Voltage node. And then we're going to have these two API endpoints. One is for request access to get the invoice and the token, and one is for protected data. So access with the L402 auth. It's important to call out here, we're having these two very explicit endpoints, but you could do this all in one endpoint. Okay, you could just have an API/data, and that data just returns you the L402 response when you haven't paid, and then when you have paid, it returns the data, right? So we're just doing these two endpoints to be a little bit explicit, but you can do it all in the same. Okay, so let's get this project structure together. This is going to be just a classic node server, pretty straightforward. And yeah, let's get this rolling. And so I'm going to make a directory. We'll do L402-demo. Okay, great. And I'm just going to open this up in my code editor. Okay, and there's nothing in this so far. We're going to add these folders, index.js, lnd.js. We're going to have a sample data.json, and then a .env. So let's get these files in here. What was the other one? Sample data.json. And don't forget .getignore so we don't push our secrets.env in node modules. That'll be good. Okay, it looks like we have our files here, and then we're going to run these commands, npm init-y. That will initialize our new server here, and then we're going to install express, axios, and .env. So let's start to do that. Okay, great. And that initializes our package.json. Let's do npi express .env axios. I think that was it. And that should install in a second. Okay, so this looks like our project structure. And then this is the sample data structure we're going to put inside of sample data.json. So we can copy this right inside the slides. So convenient. It's not like that with Google Slides. I just moved over. Sample data.json. We'll just paste this right here. So these are our two products. We have product 1 worth 1,000 sats, premium API access, and then product number 2. And then there's protected data that's returned with that. And so once again, we're being a little bit explicit here, more explicit than we need to be. But yeah, you know, I thought it would be helpful. So that's our sample data. Let's continue on. Okay, so we're going to start in lnd.js here, and we are going to create our LND connection. And we're going to use Axios for this. So I'll copy these lines, and we'll kind of explain what we're doing here. Pretty straightforward so far. So we import the Axios library, which gives us Axios, which allows us to do HTTP calls. .env will pull in our environment variables, which are grabbing right here. So macaroon and host, these are going to be secrets from our Lightning node. And so macaroon is going to be our secret token that we have to talk to our Lightning node. And then the host is, of course, just the location of that. And so we create this LND Axios instance that has a base URL. Notice the 8080 there. That's the port for REST on LND. We have the header for gRPC metadata macaroon. This is how we authenticate with our node. And now with this instance, we can kind of reuse it for any different methods we use to call on our Lightning node. Great. And so let's add the first one of those methods, which is lookup invoice function. So we'll copy this. And I have right here a link to the method in the LND docs. And so lookup invoice, this is actually, this is an endpoint that a lot of people can find tough, mainly because of the encoding. So this method will allow us to look up an invoice by what's called the R hash string, which is sort of, you could think of it like the public key of an invoice. And we take that in, we need to check if it's base 64. We need to turn it into a hex hash. If it is base 64. Otherwise, we have the R hash string and we pass in here. So a little bit of encoding madness right here. Convert from base 64 to hex if needed. That's basically what it says. And so this is the V1 invoice, and we've got the hex hash that we'll look it up by. And we simply return response.data. We also have a console log for response.data. If there's an error, we'll catch that error in this catch. Awesome. So that's our first LND method, lookup invoice. Then we're going to have add invoice, which will allow us to create new invoices for our users to pay. So let's add this below. Add invoice. Once again, we have the link up here. And we are simply just calling v1 invoices with an amount getting passed in. We console log the response, return the data, or we catch an error. Sweet, that's pretty straightforward. Okay, and next is going to be the server setup. So on LND, I mean, we have all of the LND interface pieces in place we already need. You literally just need these two methods. You need to be able to create an invoice and then look up that invoice. That's all you need. So it's actually a pretty simple implementation once you understand it. Okay, so server setup, this is going to be in index.js. Let's copy these first few lines of code. It's going to be our imports, stuff like that. Okay. So we're bringing in Express and crypto. We're creating a new app with Express, basically starting our Express instance. We set aside a port. We're importing our sample data. We're importing our methods from LND. And then we have macaroon store and pre-image store. And so these are just new maps. So they will be short-lived instances that will, you know, get erased every time you restart this server. But this is basically just representing the database that you might have to track your user's authentication, right? Because, you know, I wasn't going to build a database with this. So this is like our temporary database that will allow us to go through the full flow. So yeah. And then we have app.use express.json. So this is just middleware to have Express use the JSON format. Okay, so step 6, we're going to have a generate invoice function inside of index.js. And we also have generate macaroon right here. It looks like we're slightly out of room. Should be able to copy this though. Yeah, I'll just get that title in there. So let's drop this below. Get rid of our, our title there. Okay, so these are going to be, so generate invoice, we'll call our add invoice method from the LND connection and sort of just, what are we doing here? We're grabbing the R hash and we're setting it to our store. And so we will update that when paid. So we have kind of a payment hash, and then the pre-image will be the two items that we store together inside of the pre-image store. And just to kind of reemphasize, I mean, I know that sometimes this language can get confusing, but really, really simply, the pre-image and the R hash, these are like a lock and a key. The pre-image is like the key. It is the secret aspect. And then the hash is like a lock. It's not really a great analogy, actually. I think it's practically a great analogy, but that's how you should think about these. So the hash is the public element that you can show off to people, that you can pass around and reference, but the pre-image is that secret. And really what's happening in the background is that the pre-image is just a random string that gets hashed with SHA-256, and that creates the hash, right? So then the hash can only be reversed, or it cannot be reversed back into the pre-image because you've got this one-way hashing function with SHA-256. So I guess a little more specifically, that's what the pre-image and the hash are. So this hash is this public element that we're setting aside first, and we're sort of saying, hey, hope the user, gets the pre-image from this. Okay, and then we return the payment request from this function. We have a generate macaroon token, and for this, we are simply just, we're taking in the payment hash. We're just generating random 32 bytes in hex and just associating them too. Because really this macaroon is just a unique token, a unique challenge that we give to the user, and that challenge will be sort of made legit through them paying the invoice and providing us that pre-image. Okay, so those are those two helper methods. Hopefully I didn't confuse you there with my ramblings. Okay, we're going to have two more helper functions right here, and this is going to be some of the L402 stuff. So trying to break this up and make it modular so you can sort of see the steps coming together. So we've got verify payment, takes in the payment hash. So this is going to be checking if the invoice is paid after the user is claiming they've paid it. So we simply just look up the invoice by that payment hash, and we know this lookup invoice will handle any encoding. And if invoice.settled, we know it's been paid, and we can kind of complete this preimage store set by adding the preimage to it. We return true, otherwise we return false. It is not paid, or we error out. And then the verify L402 credentials. This is another helper method, and this will, when the user's coming back with us with that L402 request, we're going to need to check some things. So this is us checking some things. Okay, here's a payment hash. First of all, we make sure that that payment hash exists and is associated with the macaroon that the user passed in. We make sure that the payment is settled, so we call verify payment. Then we make sure that the preimage matches. So the preimage that the user is giving us matches the preimage that we verified ourselves right here. So then we have a little bit of encoding here. Stored preimage becomes stored preimage hex. And then we just compare that to the preimage. So these should be exactly the same. And finally, this is our big middleware function for orchestrating the full L402 process. So looking at that auth header, macaroon, making sure they're present. Otherwise, we return that 402, payment required. And then here we extract the preimage and the authorization header, and just make sure that the scheme has the correct name, L402, and we make sure that those credentials are valid. So kind of just a bunch of checks here, a bunch of really almost redundant checks, because all we're doing is making sure that that invoice we gave you is actually paid. You're the one that paid it. You're providing proof of us, and you're following this L402 format. Okay, onward. And then here is our first endpoint. This is going to be the request access endpoint. So we have all the helper methods in place now. We're going to create request access endpoint. And this is going to be the first endpoint that we hit to try and get a product. So let's drop this here at the bottom. Nice. So the user requests access. They're going to give us a product ID. We're going to find that product ID, make sure it exists, generate an invoice, generate a macaroon, and then return it all in that L402 process. So this is going to be our first response. They provide the payment hash for that invoice so we can check. We're not getting man in the middle. They give us the invoice. They give us the macaroon. And then we can pay it and start to build our response back to them, which will be checked right here. Okay, so that is the request access endpoint. And yeah, otherwise we just error out. And then there's the protected endpoint here, which the user should be able to hit with their authentication. So protected route with L402 authentication. We have this check L402 auth middleware, which is this guy right here. And yeah, simply you either pass through this middleware, hitting this next, or you don't. If you don't, you didn't pass the check. Otherwise, if you did, we return the data to you. So very, very explicit there. Okay, so all of this is looking good. We've got LND inside of here. These aren't lit up. Oh, I need to export these. We need to export these. Module.exports, look up invoice and add invoice. So be sure to do that. Don't miss that piece. Formatting my code. Okay, great. Those should be all of the pieces. I think we're probably going to test it out now. Yep. So testing the server. So hopefully this will make the full process and the full code as clear as possible. We're going to do a few curl commands here. But first we need to set up for testing, right? So we created a .env file. We haven't put in any credentials yet. We did actually create our sample data.json, so that's good. And then the third step would be start the server. So let's start to get these LND credentials. And so we are going to be using a Voltage Lightning node. This is my Austin dev node here. And if you don't have a Lightning node, you can go to voltage.cloud, and you can sign up here for free with just an email, and you can actually get a free development node just like I have here. And this is called a MutinyNet node. And MutinyNet is just a Bitcoin and Lightning testnet, basically, that allows you to have cheap and fast transactions, which makes it very easy for testing compared to the other testnets. So MutinyNet is technically what we call a SIGNet. So it's sort of like a controlled Bitcoin network that works just like Bitcoin with a slight few differences. One of those differences is that you got 30-second blocks. So all of the on-chain transactions go through very fast. And running Lightning on MutinyNet is just development heaven. It makes it so much easier to develop on Lightning than it ever has been. And so I'm going to unlock my dashboard here for my MutinyNet node. And if you're starting from 0, you will need to make sure to get a balance. I already have a balance. We have a faucet built right here into the dashboard, so it makes it very easy. You just make sure you have some on-chain coins and then have some channels open to you so you can, send and receive payments. But that's all good for us. So I'm just going to grab first piece of info I need right here, this API endpoint, which will be our host. So let's go into .env and we're going to do host equals this guy. And then next I'm going to grab my macaroon, which is my permissions token. So you can actually bake what's called an invoice macaroon, which only gives invoice permissions on a node, meaning basically that permission token is able to pay you and able to create invoices on your node, but it's not able to send money. So you could actually use this for this setup and have a little bit more security. I'm just going to use my admin macaroon here, which gives full permissions, which is fine because this is just a development node. So I'm going to say macaroon equals and paste and make sure you can't see that. Okay, so we have the macaroon, we have the host, we have sample data.json. So let's start our server with node index.js. Index.js. Okay, it started up. Okay, so let's request access. We're going to make our first API call. So we're going to copy this curl command. And so this is basically calling localhost 3000 API request access with just the content type header. And then the data is product ID of 1. So we're going to ask for that first product. We're going to see what we get. So I'm going to take this, I'm going to zoom in. Okay, that should be close enough to read everything. Yeah, I think so. Okay, so requested access. And it says payment required. Okay, so that first part works. That's good. We've got our www authenticate, L402 token equals, and this is the hash. So this www authenticate, we don't really need to do anything with this. What we do need though is this invoice, which we're going to pay, and then this macaroon, which we're going to use after we have paid. Okay, so let's grab this invoice and let's pay it somehow. The easiest way to pay it will be if you go to faucet.mutinynet.com. Otherwise, you can just use your own node. You know, I could use my node here, but I'm a little bit lazy, so I'll just paste it in right here, and we'll have MutinyNet Faucet pay for it. And it will pass us back the pre-image. Paid the invoice, here's your proof. Great. Okay. So we'll just keep this open. We'll keep that pre-image available. This is the response we got. Okay, so things are looking good. Let's go to the next request. So copy the L402 invoice value. We did that. Pay it using any Lightning wallet. We did that. And then save the pre-image and macaroon values. Okay. And our next protected data curl command will look like this with these two headers that we add. So let's just get this pasted in and we'll edit it a little bit. Okay. So this is showing us exactly the format expected. So L402 macaroon, and we want to grab the macaroon. We have the macaroon right here, so I can copy it. Beautiful. And then I've got the pre-image still right here. So we'll get that pre-image, put that in its correct place. And remember, it's L402 in a white space, and then the pre-image. All right, so this is our proof of payment. Our server should be able to validate this with our Lightning node. Let's see if it works. Live demo. Boom. Success, true. Data, ID 1. This is some premium content, baby. Protected content. That's awesome. Look at that. We actually got both of the pieces of premium content there. Was that supposed to happen? Request access. Sampled. Yeah, it just returned us all of the protected data. We should probably take what request.query.id or something like that. It'd be like request.data. Yeah, I'm not sure. But okay, could implement some more controls on there, but our overall flow worked. This is the response we expected to get back. Success true. Data. Message. So slightly different output. But that's okay. That's just more code to be added here. So awesome. So let's look through these logs and we'll kind of see these responses as everything ran. So here's where we started the server. Let me zoom in even more for you all. Cool. Here's where we started the server. First, we have the add invoice response. We see some of the info is giving us, such as the R hash, which went into our first response. And then the lookup invoice response. So this was called whenever we came back after paying the invoice, claiming to have paid the invoice. So they looked up that invoice, found this payment request, settled equals true. It was 1,000 sats. That sounds about right. State is settled. Nice. Yeah, and I mean, really, that was our two LND calls right there. So it seemed to work. Ooh. Awesome. Nice. So you sort of are seeing what I was talking about before. I think the most confusing aspects are the headers, probably, and then some of the checks you need to make. But besides that, we have the flow down tight. The headers seem correct. So yeah, I think this is all working pretty well. Okay, and so that complete flow, once again, the client requested access for a specific product. We created an invoice and a macaroon token, which was really just a random string. We stored them together, right? Because they're associated. This invoice and this token go together. The client paid that invoice, and they use that pre-image and that macaroon token to authenticate the server. They verify the credentials, verify the headers. It says here, verifies credentials without payment lookup. Server returns protected data. Is that a mistake? That should be verifies credential with payment lookup, because we definitely do a payment lookup here. I think there is possibly a way to do L402 without actually needing to do the payment lookup, but I didn't want to do that. So that is our basic demo. What time is it? 4:40. That was about what I guessed, about 40 minutes. So once again, here's the L402 protocol spec, LND API documentation, and then of course this project code is on GitHub and on Replit. Yeah, and thank you. I want to make sure, yeah, there's, okay. Basically, these links are in the GitHub as well. And that tiny URL might be the easiest way to get to this completed project. So hopefully this is a good basic example for L402. You can kind of get the idea of it, have a simple example, and then re-implement it and do something cool with it, right? Because what we did here is an example, but this will be best shown off with your AI agent demos and your anonymous data services and all sorts of cool projects like that. So go out and build, reach out to me if you have questions or need help with any of this process. And definitely check out voltage.cloud and consider getting one of these awesome developer nodes, one of these awesome MutinyNet nodes, which you can get for creating an account. And yeah, so it's pretty fun. This is Austin once again. And yeah, hit me up if you have any questions. And I'll see you for the next Voltage Work.